Hello all, welcome. Hope you're all doing good. We are going to start another session. Today we are going to discuss some few concepts and some questions from chapter units and measurements, and also motion in a straight line. Okay, the first two chapters, actually physical world was a deleted chapter for us, right? And we started with units and measurements, then followed by the first two chapters in 11th of part 1. Okay, as far as units and measurements is concerned, it was like always we say like that, no? Just like having a soup before a heavy lunch. That was an introductory concept which we use it throughout in our discussion. So units and measurement is not actually a chapter. It is an introductory concept which we used throughout our discussion in 11th and 12th, right? All the concepts. Topic wise, when we come to units and measurements, systems of unit, we know the fundamental unit systems, the basic unit systems like MKS, FPS, CGS. I'm not going to the details of that because it is quite easy for us. And SI unit system, 7 fundamental quantities of SI unit system, right? It's unit, like SI unit values, its symbols, we know all the basics of that. Then dimensional analysis, the next important topic. And there was a deleted portion for us, like errors in the measurements. So my discussion will be mostly concentrating in that particular topic today, because we already know how to deal with units and dimensions. Okay, so we definitely will do some questions from that also, but I will introduce that errors and error calculation mostly in this discussion. Okay, first part of the discussion. And finally, significant figures. Right. And from this chapter, units and measurements, average of 1 to 2 questions we expect for NEET. Right, when you go to the past papers, you can see 1 or 2 questions. Every year we get 1 or 2 questions from units and measurements. Sometimes it can be like from dimensions or from errors, okay, or basic unit systems. So anyway, we expect an average of 1 to 2 questions. Okay, so the system of units we know, we'll start straight with the questions from that. We'll discuss whatever it is necessary, okay. Most of the questions will be easy for you because units and unit part is easy. Which relation is wrong? That is question number 1. Let us start with the questions. Okay, first one, which relation is wrong? I hope you can start answering now, because all these questions we know. I mean, all options are given like basic units. So hope you people can start answering. First one is given as 1 calorie is 4.18. Yes, Sri, I got the first answer. Let us wait. 1 calorie is 4.18 joule. You're asked to select the wrong one, okay? Wrong one? Yes. 1 angstrom is equal to 10 raised to minus 10 meters. 1 MeV is equal to 1.6 into 10 raised to minus 13 joules. Yes. 1 Newton is equal to 10 raised to minus 5 dyne. Yes. Which one is incorrect? Which is the wrong relation? Okay, see, we know calorie. Calorie is, okay, Hafiz, both of you check that answer, like the one which you gave me. 1 calorie. Calorie is the CGS unit, right? It is the CGS unit of heat, we know. CGS unit of heat. 1 calorie is equal, 1 calorie is equal to 4.18 joules. That is a correct relation. First option is correct. Second one, 1 angstrom, unit of length, right? 1 angstrom. Usually we measure atomic size. In this unit, 1 angstrom, or like wavelength of electromagnetic radiation. So you measured in angstrom. So that is 10 raised to minus 10 meter. That is also correct. And yes, Hafiz, now you realize, right? The option C is going to be 1 MeV is 1.6 into 10 raised to minus 13 joules. We know 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules, right? Yes, but you're given MeV. MeV stands for mega electron volt, right? Mega electron volt, unit of energy. Mega electron volt is going to be 1.6 into 10 raised to minus 19 joules into 10 raised to 6, right? Because mega electron volt. So it will be 10 raised to 6. 19 and 6 is going to be 10 raised to minus 13. Option C is also correct. Right? Both of you gave me B as the yes. Exactly. C as the answer, but that's a correct relation. And finally, the last one, D. What is the mistake in this relation. 1 Newton is 10 raised to minus 5 dyne. Newton is SI unit of force. Dyne is CGS unit of force. But the relation is just the other way around, right? Yes, sorry, exactly. 1 Newton is 10 raised to minus 5 dyne is wrong. But 1 dyne is equal to 10 raised to minus 5 Newton is the correct relation. So D is the answer, the wrong relation in the given options. See how simple the question is, but we commit mistakes, careless mistakes. Okay, moving on to the next one. Question number 2. Torr. Torr is the unit of, come on. Torr is a, I'm waiting for you because these are like the very basic concepts. So, giving you a chance to answer the questions. Come on. Torr is the unit of, this is an easy one. Yeah, exactly. We have pressure, volume, density, and flux. Have you heard of the term, like name of the scientist, Torricelli? Exactly half is Torricelli barometer. Torricelli, the major contribution of Torricelli was like he was a Italian physicist, mathematician also, and he introduced Torricelli barometer to measure the pressure. So the unit of pressure is like named after his name, Torricelli. But Torricelli was not the SI unit of pressure that we know. SI unit of pressure is actually Pascal, right? Pascal. And we have 1 Torricelli is equal to 133.3, okay? Pascals, 133.3 Pascals. That is the relation anyway. But Torricelli is the unit of pressure, first option. Correct. Moving on to the next. Yeah, slowly we are coming to the dimension part. Like, you know, dimensional analysis, we had some 3 applications we discussed in the, 3 different applications of dimensional analysis, and the key concept of that was principle of homogeneity of dimensions, right? Hope you remember principle of homogeneity of dimensions. It says that in a physical relation or in a physical equation, quantities on LHS, like dimensions of each quantity in the LHS should be equal to dimensions of each and every quantity in the RHS, right? That was the relation, principle of homogeneity of dimensions. And we defined in another way also the same concept, that physical quantities of same dimensions can be added, subtracted, equated, or compared. 4 operations: addition, subtraction, equation, comparison. These 4 operations can be performed only between quantities of same dimensions. Okay, that was principle of homogeneity of dimensions. Based on using that particular concept, we discussed 3 different applications. In the first application, we checked correctness of an equation, right? We have to check whether dimensions of each term on LHS is equal to RHS. If they're equal, we say that equation is dimensionally correct. Hope you remember that. Second application was, we say dimensionally correct because we are not sure about the constants. Equation may be correct or incorrect, but dimensionally that equation is correct if dimension of LHS is equal to RHS. Then second application was to derive relation between various physical quantities. Okay, and third one, some quantities will be given. We have some examples to discuss. Using that quantities, we have to derive relation for a given physical quantity. Okay, third application was to convert from one unit to other. Okay, we get repeating questions from dimensional analysis based on this principle of homogeneity of dimensions. Okay, look at this question. S is equal to A into 1 minus e raised to minus bxt, where s is speed and x is displacement. You are given s is speed and x is displacement. Okay, fine. The unit of b is, what will be the unit of the term b in the equation? Where can you see b? B is given as the power of e, right? E raised to minus bxt, right? So let's see, what is s? S is the speed. S is the speed. See, when you get e raised to x, exponential function, what comes to your mind? What about the exponential functions? Exponential function, logarithmic function, yes, logarithmic functions, trigonometric functions, yes, trigonometric functions. All these are what? They are dimensionless quantities, right? There doesn't have any dimensions, dimensionless. So we have an exponential function in this equation. correct? So whatever comes as a power of the like e raised to the exponent of e, that particular, like the power of e, that should be dimensionless. Whatever comes as a power of e, that should be dimensionless, because the exponential function is a dimensionless function. Similarly, logarithmic function or trigonometric function. See, for example, if we have sine a by b, suppose y is equal to a sine a by b is given, a function, for example. Like, what should be dimension of a and b? Then dimension of a should be equal to dimension of b, because whatever comes as an argument of the sine function, the trigonometric function, it should be an angle, plane angle, right? Theta, and theta is dimensionless. Here, instead of theta, we got a by b. A by b will be dimensionless only if dimension of a is equal to dimension of b. Okay, similarly, if it is e raised to, suppose y is given as some a into e raised to a by b, the same example, a by b. Here also dimension of a should be equal to dimension of b, then only e raised to that term will be dimensionless. Okay, right. Now look at the equation given, that is s is equal to a into 1 minus e raised to bxt minus bxt. That is what given. Equation 1 minus e raised to minus bxt. Okay, fine. So that is the equation given. See, s is the speed. It is going to be L t raised to minus 1. Fine. Before that, let us open the bracket here. A minus a into e raised to minus bxt. That is s. Got it? Fine. According to the principle of homogeneity of dimensions, we can say dimension of s should be equal to dimension of a. Yes. And that should be equal to dimension of e raised to minus bxt. So that e raised to minus bxt should not have a dimension. Then only this equation is true, right? Yes. So what are the terms we get on the like as a power of it? B into x into t. This should be dimensionless. M0, L0, T0. That is what we understood from this, right? The power of E should be dimensionless. Okay, B, X, T. So what will be dimension of X? Dimension of B is to be calculated. That is going to be M0, L0, T0, dimensionless, divided by dimension of x into dimension of t. And question says what is x and t, right? Question says what is x? What is x? X is the displacement. And what is t? T is the time, correct? Yeah, x is the displacement and t is supposed to be the time. Okay, fine. Then what will be the unit? Dimension. So we get m0, l0, t0 divided by l into t, correct? L into t. So that comes up L raised to minus 1, t raised to minus 1. This is the dimension of B. Yes, yeah, okay. Hafiz, Shreya, you just check that answer, okay? The one which you give me the last one. Okay, so we got the unit of, you're asked to find out the unit of B, and we got the dimension of B. Dimension of B is length inverse, time inverse. So it is going to be meter inverse, second inverse will be the unit, right? If you know the dimension, we can easily calculate unit. Length is measured in meter, time is measured in seconds. Okay, so we got meter inverse, second inverse, that is what? Option A. Yeah. Right, so the concept is, if it is a logarithmic function, exponential function, or trigonometric function, whatever comes in that argument, like, as I told you, sine, it should be sine theta. Whatever comes in this argument should be plane angle. Plane angle is dimensionless. Okay, e raised to, whatever comes as the power of e, that should be dimensionless. Log something, right? Logarithmic function, log something, this should be dimensionless. Whatever comes in that argument should be dimensionless. Okay, fine. So this is the answer for the third question, right? Option A. Hope it is clear. Moving on to the next. Velocity of a freely falling body changes as g raised to p and h raised to q, where p and q values, see, the question is where p and q is, right? Value of p and q. Right, the second application, right? We derive expression for velocity of a freely falling body. If you know that equation, we can save the time. Any body which is falling freely under gravity, its velocity after a particular distance. If something is dropped from a height after covering a h, distance h, what will be the velocity? It is root of gh, 2gh, right? Root of 2gh is the equation. If you know that equation, your like that problem is solved already, because g and h, the power of g and h is p and q. Actually, we get v is equal to root of gh, actually 2gh. 2 is a dimensionless quantity. So g raised to 1 by 2, h raised to 1 by 2 is the answer for this question, right? G raised to 1 by 2 and h raised to 1 by 2, both p and q are 1 by 2 each. So option B is the correct answer. Yes, Hafiz. Okay, if you don't know this equation, then what is the next option? That was the application of second application of dimensional analysis actually, right? If you don't know this equation, suppose v is equal to root 2gh equation, we don't know, or some other complicated equation is given, then what will we do? Okay, that we will discuss. I think in the next question we have something like that. Okay, fine. So here v is equal to root of 2gh, that is a known equation, so easily we could solve question number 4. Option B is the correct answer. Okay, fine. Moving on to the question number 5. And look at the question. Question is talking about frequency. Frequency is the function of density. The first one is rho, density. And it depends on length. A stands for length. And surface tension, T. Surface tension, T. Then its value is, what will be the value of that frequency? How will you find out the value of frequency, or which equation represents the frequency is the question. 3 factors given, 3 quantities that decides the time period, not time period, frequency are density, length and surface tension. Principle of homogeneity of dimensions, right? Or using method of dimensions, we have to derive exact equation to identify which equation is the correct one. Okay? Yeah, so what to do? You are given frequency. What is the dimension of frequency? We know frequency is a reciprocal of time period, so t raised to minus 1 is the dimension of frequency. What are the other quantities given? Density. Density is actually mass by volume. So mass, dimension of mass is m, volume is L3, right? So we can say m L raised to minus 3 is the dimension of density. So second quantity is also, first quantity is ready, right? Now length, A is length only, so dimension of A should be equal to dimension of L, length. And finally surface tension. We know surface tension, right? Surface tension is measured as force per unit length. Yes, so surface tension is going to be dimension of surface tension, dimension of force by dimension of length. So ml t raised to minus 2, that is the force, mass into acceleration, divided by length. So L gets cancelled. Dimension of surface tension is going to be m t raised to minus 2. We got dimensions of all the physical quantities that comes in this equation, correct? Yes, time period, frequency, density, length and surface tension. Okay, so we have to formulate an equation for time period. Time period is equal to, sorry, not time period, frequency you are asked to find out. So frequency F is equal to, right? We usually say it is proportional to, the first one is density raised to A, then length A raised to B and surface tension T raised to C. We can say F is equal to some K. See, in all the options we have a K. That K is a dimensionless proportionality constant. Density raised to A, like length raised to B and surface tension raised to C. Now we know what to do. We will substitute the dimensions of each and every term and we will equate the powers. Finally we get what is the expression for frequency, right? And that will be one of the options here. Okay, so we'll quickly go for that. See here we can say on the LHS we have t raised to minus 1, right? T raised to minus 1, that is the Dimension of frequency, reciprocal of the time period, t raised to minus 1. Okay, density we already know. Density is ml raised to minus 3, ml raised to minus 3, the whole raised to a. Then dimension of a is length only raised to b, and dimension of t, that is the surface tension, which is mt raised to minus 2, yes, the whole raised to c. Simplify. We have m raised to a, l raised to minus 3a, l raised to b, okay, and m raised to c, t raised to minus 2c, that is t raised to minus 1 on the side. Got it? Yes, t raised to minus 1, and we have so many other terms on the RHS. So let me just move on to the next page. M raised to a and m raised to c. We have two terms for m. So dimension of LHS is t raised to minus 1 is equal to m raised to a plus c, correct? M raised to a m raised to a plus c, m raised to a and c taken together. Right, then what about L? L has b and minus 3a. So we can take L into b minus 3a, and for t, what's the power? Power of t will be just minus 2c. We have only one term with power c, correct? I mean, sorry, one term with time dimension on the RHS is only 1, so t raised to minus 2c. Okay, t raised to minus 2c. So on LHS, no m term, no L term, t raised to minus 1. M raised to a plus c, L raised to b minus 3a, and t raised to minus 2c. Now we have to solve this equation to find out the final answer. So make it quick and tell me what is the final answer. Okay, find out a, b and c. Then we will find out what exactly is the dimensions there on the equation. Fine. So let us go for equating time. T raised to minus 1 on LHS, t raised to minus 2c on RHS, right? So we can say minus 1 is equal to minus 2c, or c is equal to 1 by 2. We got value of c, 1 by 2. Good. And then what about m? We have m raised to a plus c, and LHS we have m raised to 0. So a plus c is equal to 0, or a is equal to minus c. We already found out what is the value of a, right? Value of c we know, so therefore a is going to be minus 1 by 2. So we got a and c solved already. Now we can easily find out b. For b, power of a, right? Power of L. So b minus L raised to 0 is equal to L raised to b minus 3a. So b minus 3a is equal to 0. So 3a is equal to b. Therefore, what will be b? Substitute the value of a there. It is minus 3 by 2. So 3 into minus 1 by 2 is going to be minus 3 by 2. So this is your option B. Correct? So when you come back to the equation, what is your equation? Frequency is equal to some k into density raised to a, then length raised to b, and finally surface tension raised to c. That was the equation, right? That is what we started with. This is the equation we have. Substitute a, b and c respectively, then we get F is equal to k into density raised to a, that is density raised to minus 1 by 2, length raised to b minus 3 by 2, and what is tension, surface tension raised to 1 by 2. Okay, so the equation is supposed to be k into, right, t raised to 1 by 2 divided by rho raised to 1 by 2 into a raised to 3 by 2. Correct? Do we have any matching option? T raised to 1 by 2, that is root of t. Correct? So k into root of t divided by root of like density into a square, right? Sorry, a cube. That is what the final relation. Now check the options. If you have any option like this, root t by root of rho r rho a cube, that will be the answer. So rho is 1 by 2, rho 1 by 2, rho 3 by 2, we get both of the options A and B, A and C, we get rho as 1 by 2, power of 1 by 2. T is given as root 3, it is half only, but it is in the denominator. Here it is supposed to come in the numerator, right? And A raised to 3 by 2, T, no, this is not an option, this is also not an option. Then here, not 3 by 2, it should be 1 by 2. A value is 1 by 2, no? Rho raised to 1 by 2. Yeah, yes, so none of them are matching. Option is D. Okay, so the method, I was just looking for the method, like what to do with the like given dimensions. We found out dimension of each physical quantity, and then we equated dimensions of physical quantity by forming a relation. We substituted dimension of force, dimension of density, length and time, surface tension, not time period, surface tension. Okay, and then we equated the dimensions, found out the power, equated the powers, we found out A, B and C respectively, and substituted in the equation. We got some final expression and we found out the final answer from the question. Okay, so this is the way how we have to do if you don't know the equation exactly. I told you the previous question, here we knew the equation V is equal to root of 2gh. That is why easily we predicted it is g raised to 1 by 2 and h raised to 1 by 2. Value of P and Q was 1 by 2 each, since we know the equation. But in question number 5, we didn't know the equation. It is a new equation we derived. So we found out the expression actually. Then only we can, like, you know, by applying method of dimensions, we found out the equation, then we selected the answer. Okay, so the stepwise process, hope you remember, we start with a relation, we start with an equation by introducing a constant, then substituting the dimensions of each physical quantity is given with powers A, B, C or X, Y, Z, whatever it may be. Then we will find out the values of A, B and C and we will substitute it back in that equation, so we will get the final expression. Okay, yes Hafiz, it was option D, that is none of the options are matching. That you can decide only just by finding rho itself, right? Whenever we got A value, see A is 1 by 2, sorry, minus 1 by 2. A was minus 1 by 2, yes, and none of the options says A is minus 1 by 2. Okay, fine, that was question number 5. And look at the 6th one. Energy, mass, L for angular momentum, okay, angular momentum, and G denote, see those corresponding terms. Then the quantity E L square by m raised to 5 G square has a dimension of. See, we know all the dimensions here. They are just testing us with, do we have the patience to find exactly what is this ratio, right? Then you will get, you can easily select one of the options by checking this ratio. And it is raised to some powers also, so be careful. We know dimensions of each of these quantities, it is easy, okay, but be careful when you substitute the values, and you have to identify the terms one by one. Energy, right, the first one, E is energy, E, and value, dimension of energy is going to be ml square T minus 2. Everybody knows this, right? ml square T minus 2. We remember kinetic energy equation. Kinetic energy is equal to half m into v square. Half is dimensionless constant, m is the mass, velocity L minus LT minus 1, it is squared, L square T minus 2. Dimension of energy. Whatever may be the energy, all energy forms will have the same dimension, right? Whether it is kinetic energy, potential energy, electric energy, magnetic energy, whatever it may be, energy has one single dimension. Okay, so what energy is not an important question at all. Now the second one is L. Remember, L is not the length. One of the common mistake we commit in this solution, in these kind of questions, is like when we see L or M, we will decide that is length or mass. So check the question. Here L stands for like energy, mass and angular momentum. L is angular momentum. We know angular momentum can be calculated as mvr, right? That is the easiest equation we have, rp sine theta. Sine theta doesn't have any dimension. P is mv, so r into mv, which is mvr only. We know angular momentum of electrons, right, in Bohr orbit is nh by 2 pi. mvr is equal to nh by 2 pi. So mvr is the equation for angular momentum, which will be, m is the mass, so m, what is v? Lt raised to minus 1 velocity, and what about r? R is radius, one more L, so dimension of angular momentum is going to be m L square T minus 1. Yes, angular momentum is ready, L is ready, and that should be squared. So what will be L square? If you go for L squared, see, you have to substitute L square in our equation. It becomes m square L raised to 4 t raised to minus 2. Okay, be careful. Right, so we are okay with the nominator part, EL square. Now the remaining is m. What is m? Check m. M is the mass. Yes, so it is easy. M is the mass, so m raised to 5, we can take m raised to 5 only. Yes, no worries. Then G square. G is what? What is G? G is given as gravitational constant. Yes. And that dimension we usually don't remember, right? If you remember, it is good. If you don't remember G, just find out that dimension first. I told you before also, G can be equal to Fr square by m1 m2, right? Gravitational force. F is equal to G m1 m2 by r square. G m1 m2 by r square can be converted to G is equal to Fr square by m1 m2. F is the force, mlt minus 2. R square is L square divided by m square. M1 into m2 is going to be m square. So one of the m gets cancelled. We get m raised to minus 1. See, m square comes up. M raised to minus 1. L raised to 3. T raised to minus 2. This is the dimension of G. M minus 1. L3. T raised to minus 2. But that is squared again. So what is your G square? Yes, so G square is going to be equal to m raised to minus 2, good, L raised to 6, and finally T raised to minus 4. Yeah, we have all the terms. Just take the ratio. You can see that final result will be matching with one of these dimensions. Okay, so only be careful in the calculating those dimensions. Now the simplification is very easy. Yes, Hafiz, tell me the last one, like the final answer. Yeah, okay, hope you have these dimensions with you. I'm going to change this page, okay? And we have to substitute for EL square m raised to 5, EL square divided by m raised to 5 G square. Let's take the ratio one by one. What is E? Energy is just E only. E is going to be ml square T raised to minus 2. ml square T raised to minus 2. Okay. Into, what is L square? Angular momentum square. That also we found out. L square. M square L4 T minus 2. M square L4 T minus 2. Okay. Nominator is ready. Divided by, what is that quantity M? It is mass only. Mass raised to 5. Okay. No confusion. G is the gravitational constant, which we already squared and kept here. Where is it? G square is going to be m square L6 T minus 4, right? M square L6 T raised to minus 4. Ready for cancellations. You can cancel many of the quantities and find out what is remaining finally. Yeah. See, we have m square already cancelled, correct? Yeah, m square is cancelled. Look at this, L raised to 6, L square, L raised to 4, L raised to 6 is cancelled, correct? Then T raised to, what happens here? T raised to minus 4, T raised to minus 4 gets cancelled. Done. And then what about M? E, L square is m square L raised to minus 2. G is G square m raised to minus 2 L6 and m raised to 5. Angular momentum is m V LT minus 1, R is L. So L square T minus 1. So if you square it, m raised to 2, L raised to 4, m raised to 5 here. We miss something. M square is cancelled. T raised to minus 4, T raised to minus 2, m raised to minus 4. Mass, energy, angular momentum, gravitational constant. Yes, so energy ml square T raised to minus 2. Then L, angular momentum, mvr, mass, L T minus 1, r is a radius, so ml square T minus 1. L square is going to be m square L raised to 4 T minus 2, correct? G, let us check G. Power of m is minus 2. Wait, which power we have taken? G. G is m raised to minus 2. Yes, we substituted that as, sorry, so that is minus 2. Instead of that I put plus 2. See the way how we commit mistake. Yes, so m square here, so it goes up, so we will get totally, yes, completely will be cancelled now, right? Okay, exactly. See, this was a mistake. Instead of m raised to minus 2, I substituted. See, this was the dimension we got. It's supposed to be m raised to minus 2, but I put by mistake m raised to plus 2. Now what happens? See, here m square goes up. See, now I cannot cancel this. Let me just take all the m's back, okay? Because we cancelled in the wrong way before. So there was m square, correct, m square. Yeah, now look at this. We have m raised to 2, so it becomes m raised to 3. M raised to 3, this also will go up, so it becomes m raised to 5 altogether, right? Yes, m raised to 5 and m raised to 5 completely cancels. Only remaining terms are now m's. See, look at this. M into m raised to 2 is going to be m raised to 3. This will come up, m raised to 2 divided by m raised to 5. So what happens? Completely cancelled. No dimensions remaining, right? So the quantity is dimensionless. M0, L0, T0, right? But you are not given any options like this. You are given some physical quantities. Angle, mass, length and time. Now at once we can solve this, because the only dimensionless quantity given in these options is plane angle, right? Angle is dimensionless. So it has a dimension M0, L0, T0. Yes, we solved it. See, be careful when you copy like this, don't commit mistakes. See, all quantities were given and only G was a little confusing to us, because normally we don't remember that value. So just remember that also if you can. Otherwise, within 2 steps, we'll get the value of G, getting derived from F is equal to G m1 m2 by r square value. And angular momentum was another new quantity, which is mvr. We know the equation. So we found out that dimension also equally. Then they powered, some powers are given. So accordingly, we powered and simplified. Option A was the answer. That was completely cancelling. Dimensionless quantity we obtained. So it is option A, angle. Good. Now, moving on to the next one. Question number 7. Yes, these questions, this is coming from the error part. So I'll just run through that concept quickly to get some basic idea about how errors can be calculated and what type of questions or what type of errors we have to calculate and how it comes in the questions. Okay, that's what we are going to discuss quickly. Okay, see here, errors in a measurement. When we measure, we usually have to measure a physical quantity. See, if I want to calculate the momentum of this pen, I want to measure its mass first, right? Mass, I have to measure it using a weighing scale. Yes, and then we will measure the velocity. Or if I want to measure the area of this board, so we have to take the length and breadth. We have to measure the breadth, length and breadth, okay? Then we calculate the area. So whenever you measure a physical quantity, there is a possibility of committing mistakes. See, when you multiply 2 and 3, it will be 6. Hopefully, it is 6 only, right? Yeah, it is 6 always. It cannot be 6.1 or it cannot be 5.9. There is no possibility of committing mistake in this calculation. Not our calculation mistake, I mean, okay? Usually, these basic calculations cannot be wrong, like 2.3 cannot be 6.1. It will be 6 always. But when you measure something, when you measure a physical quantity, as I told you, mass of this pen is going to be measured, or length of the board is going to be measured. I am going to take a meter scale or a tape to measure the length. So my measuring ability may be different. Like I may have so many imperfections in the measurement. Like I may be taking a wrong reading. It is supposed to be 6.5 meters I have to get, but by mistake, because of my poor vision, for example, I measured 6.4 meters. So there is an error in the measurement. In this way, whenever you measure something, there will be possibility of committing some mistakes. Okay, that errors we measure. Okay, usually we measure absolute error in a measurement, absolute error, then relative error, and percentage error. Okay, these are the 3 error types percentage error. These are the three different types of errors we have to calculate, and questions will be based on any of these three. And I'll give you quickly an idea about what are these errors. Absolute error. Absolute error is the difference between actual value and measured value. Suppose I know like length of the board is 6.0 meters, for example, 6.0 meters. But I measured the distance as, or length as 6.1 meters, which means 6 meters, 10 centimeters, right? 10 centimeters is a mistake in my measurement. How do you know that? 6.1 is the actual value, the measured value minus actual value 6.0. So 0.1 meter is the error in the measurement, okay? Error in the measurement. We will take only the magnitude, not the sign. So 6 minus 6.1, supposed to be minus 0.1, right? We will never consider the sign. That is why it is called absolute error. Magnitude of the error committed. Somebody measured 5.9 meters, for example. Student Y measured 5.9. What is the error still? 0.1 only, not minus 0.1. It is 0.1 only. 6 minus 5.9. Always we will take the magnitude, absolute error. Got it? So that is called the absolute error. Absolute error. And that absolute error we will calculate. So many measurements may be given. So we will calculate the mean absolute error. So I'll give you a small example using which we can just explain these errors. Okay, then we will come to the questions. See, if you want to calculate absolute error in a measurement, you should know what is the actual value of the measurement. I knew that length of the board is 6 meters. That is why, or that is how I calculated the error in the measurement, because I knew actual value is 6. Measured value is 6.1. So we can easily calculate the error in the measurement, 6.1 minus 6, 0.1 meters. That is called the absolute error. Okay? If you don't know what is the true value. Suppose you are given a set of measurements like A1 is 5.0, A2 is 5.1, A3 is 5.2, A4 is 5.3, and A5 is 5.4. I have given some random values for the simplicity of the calculation. These are the measurements of length of something, okay? Length of a board, for example. Length of a board is measured 5 times. How many measurements? 1, 2, 3, 4, 5 measurements is given. Suppose it is meters, 5.0 meters, meter. These are the measured values. How will you find out absolute error in each measurement? How will you find out the absolute error in each measurement? What did I tell you? What did I tell you? We have to subtract each measurement from the true value or the actual value. But we don't know the actual value. Actual value, or it is also called true value, can be considered as the mean value given, mean value of these measurements. How will you find the mean value? Let me take mean of these given measurements. A mean is equal to A1 plus A2 plus A3 plus A4 plus A5, sum of all measurements divided by the number of measurements given, 5. Correct? That will give you average of this value or mean value of this measurement. Since it is continuous values, 5.0, 5.1, 5.2, 5.3, 5.4, this will be the mean value, right? Yes, even if you calculate it, see 5, that is 25 is going to be 26, right? This is going to be 1. So 26 by 5. So we will get 5.2. Okay, anyway, so this is the average value, mean value obtained, correct? Yes, mean value obtained. This is considered to be the true value or the actual value of the measurement. Yes, true value or actual value. Now, like 5.2 should be the true value. Then what will be the errors in the measurement? I have to calculate what is error in the first measurement, delta A1. Absolute error in the first measurement. See, 5.2 minus 5.0, right? 5.2 is the mean value, 5.0 is the measured value. So what is the result? 0.2 meters. Got it? Yes. So then what will be error in the second measurement? Delta A2. 5.2 is the mean value minus 5.1. That is going to be 0.1 meters. What will be this? 5.2, the third one. Third one is 5.2 only. Measured value is 5.2 minus 5.2. It is going to be 0, right? Delta A3. There is no there is no error in the third measurement because that is a true value, because that is a mean value of the measurement. Correct? Okay, then what about the next one? Delta A4. Delta A4 is 5.2 minus 5.3. I was keep on putting that modulus sign throughout to consider only the positive value. No, 5.2 minus 5.3 actually minus 0.1, but we consider only positive value 0.1. And what is A5 finally? Delta A5 is going to be 5.2 minus 5.4. That is going to be 0.2 meters. Yes. So this is called absolute errors in the measurement. Absolute error in the first measurement A1 is 0.2 meter. Absolute error in the second measurement 0.1 meter. Absolute error in the third measurement 0 meters. That is a true value. A4 0.1 meter. Error in A5 0.2 meters. These are called the absolute errors. Okay. Then we will find out what is the mean value of absolute errors. Mean value. Delta A mean. Mean value. How will you find the mean value of absolute errors? 0.2 plus 0.1 plus 0 plus again 0.1 plus 0.2. The whole divided by 5. Mean value of all these values. Okay. Correct? So we get 0.2, 0.3, 0.4 and 0.6. 0.6 by 5. Correct? 0.6 by 5. That is delta A mean. Mean value of absolute errors. 0.6 by 5, which is equal to 0.12. Correct? 0.12. Now, that physical quantity, length of the board, now can be represented as it's A mean plus or minus delta A mean. I hope you remember what are these terms. A mean is the mean value of all the measurements, which is considered to be the true value. Correct? True value, which we calculated as 5.2. Okay, then when we come to the delta A mean, that is 0.12. So we will round off this into one decimal place, 0.1, because in all our measurements we have only one decimal place. Okay, so how will you represent that length now? 5.2. A mean was 5.2. You remember A mean was 5.2, and that is going to be plus or minus delta A mean is 0.1. This is the way how that measurement can be represented. Okay, so that first term stands for true value of the measurement. True value. Actually, how many values you were given? 5 values. Okay, 5 values. 5 values you were given, from which we found out one true value. What is a true value? Actual value? Mean value of all the measurements. That's it. Okay. From using that as the true value, we found out error in each measurement. Error in each measurement. That was called absolute errors. I told you one of the error is absolute errors. Using that absolute error, we represented the quantity 5.2 plus or minus 0.1, which means the measured value has a true value A mean 5.2 meters and the error, mean absolute error 0.1 meter. This is the way the quantity will be given. Look at the question. You are given voltage V. Okay, right? Before that, we had a question here. Yes. In this one, we are going to talk about the diameters. 2 diameters are given. One is 4.23 plus or minus 0.001. See, 4.23 plus or minus 0.01 centimeters. This is the first value given. I told you this value is actually A mean plus or minus delta A mean. You got it? This is how we represent it. A mean plus or minus delta A mean. So what is your A mean value here? Average of true value of the measurement is 4.23. And what is the error? Delta A mean. Error in the measurement is going to be 0.01 meter. Sorry, not meters. Unit is given as centimeters. See? Look at the second value given. One more value given in the question. 3.87 plus or minus 0.01. See? we have two values given in this format, okay, in this format. So whenever values are given in that format, remember it is given in the form like A mean and delta A mean. Okay, I just told you about one of the errors, absolute errors, how to calculate absolute error in each measurement, then how to take its mean value, which is A mean, delta A mean, magnitude of mean value of the errors. The second one is relative error. Now the calculation is easy. Relative error is always is equal to mean value of the errors, delta A mean, we used to capital A, delta A mean divided by A mean. Means delta A mean is the error part, A mean is the true value part. In this example, what is the relative error in this measurement? Relative error in this measurement is going to be 0.1 by 5.2, correct? 0.1 by 5.2. That will be some relative errors. If you simplify that, you will get the final answer. Relative error. Okay, and the last one is percentage error. How to simplify percentage error? Percentage error is going to be this relative error into 100. Whatever value you obtain here, that can be multiplied with 100, put a percentage sign, that is your percentage error. Okay, all right, and we have to go for like combination of errors followed by this. So I hope that we will discuss in detail in another session, because it is completely new for you, right? So we have to go through that in detail, correct? Then we will do questions from that part also, okay, using all these combinations. Fine, right now we can't touch those questions, so we will discuss this after doing the module. In our regular discussion we'll come back to these questions, okay? Yes, now we have some few more minutes. Within that time we have to go for the next part also. The second chapter we introduced was motion in a straight line, right? So I told you that error part we have to do in detail in another session. Okay, in motion in a straight line part also, motion in a straight line, motion in a plane, together we consider as one unit from which we expect 2 to 3 questions, okay? 2 to 3 questions. So definitely there will be one question from motion in a straight line. If you go for motion in a straight line alone, just like units and measurements, 1 to 2 questions we expect for NEET exams, okay? And here also we have some basic concepts like what is distance, displacement, relation between distance and displacement, then velocity, speed, acceleration, right? What do you mean by accelerating a body? So not just the definitions, I mean what exactly the effect of that. See, if a body is moving in a particular direction with a speed 3 meters per second, what does actually physical sense of that motion? That concept should be clear. The body covers 3 meters in every 1 second. That is the unit, I mean that is a quantity velocity given, right? It covers 3 meters in every 1 second. So after 2 seconds it covers 6 meters from the starting point. After 3 seconds it covers 9 meters, like that. So it is easily predictable, its motion. Okay, so that kind of proper understanding of the concept of motion is very, very important in solving questions. What is the meaning of applying an acceleration on this body? The body was moving in this direction with 3 meters per second. What do you mean by accelerating this body with 1 meter per second square acceleration? If you apply acceleration of 1 meter per second square, velocity keep on increasing, right? After 1 second, velocity becomes 4 meter per second. And the next second, it becomes 5 meter per second. Then in the next second, 6 meter per second. 1 meter per second change in velocity in every second. That is the meaning of 1 meter per second square, right? It is actually 1 meter per second by second. 1 meter per second change in velocity in every second. That is 1 meter per second square. If you apply that acceleration along the direction of motion, speed is keep on increasing. If you apply the same velocity, acceleration in the opposite direction, instead of increasing 3 to 4, in the next second, 3 decreases to 2 meter per second. Deceleration, right? Decreases by 1 meter per second. In the next moment, it becomes 1 meter per second. And in the next second, it becomes 0. The body will be at rest. Okay, so this kind of understanding, like what exactly the motion, how the body moves, what is velocity, acceleration, what is the meaning of being accelerated uniformly, right? Or what is uniform motion, that kind of basic concepts you should be thorough with. And numerical questions mostly we get from this part. Okay, non-uniform motion, motion under gravity, non-uniform motion, right? The example of non-uniform motion is uniformly accelerated motion, a special kind of non-uniform motion, uniformly accelerated motion. And its example is motion under gravity. Motion under gravity, any body which is dropped from a height or anything thrown vertically upward is moving under gravitational force. It is an example of uniformly accelerated or uniformly decelerated motion, right? Okay, so that part we get repeating questions from that part. Okay, and finally motion graphs. Motion graphs is also very, very important. We have displacement time graph, velocity time graph, and acceleration time graph. How to find out a given quantity from these graphs we will discuss in detail in another session, because we're almost we have just 5 more minutes, I think. Yes, so within the time we will do as many questions as we can. Okay, right. So from this part we'll start the questions. I hope I can go straight to the questions from the basics at least. We have displacement of a particle given by y is equal to a plus bt plus ct square minus dt raised to 4. The initial velocity and acceleration are respectively. You are asked to find what is the initial velocity and what is the initial acceleration. Initial velocity means u is the velocity at the beginning of its motion, that is at time t is equal to 0. That is the only hint I have to give to find the final answer. Correct? Acceleration, initial acceleration means acceleration at time t is equal to 0. You have to find out these two values. That is your final answer. You are given displacement in the expression. Displacement of the particle y is equal to a plus bt plus ct square minus dt raised to 4. Correct? This is what given. Then you are asked to find initial velocity. How will you find out the velocity? Initial velocity? Initial velocity, we have to find out velocity for that. Initial velocity can be found out by substituting t is equal to 0 in the velocity expression. Velocity expression, dy by dt, differential of displacement, rate of change of displacement by with respect to time, yes, is going to be the velocity. What will be the differential of the function? This is going to be 0, right? So second term will be just b. D by dt of t is going to be 1. Here ct square becomes 2ct, correct? 2ct. The last term will be minus 4 dt cube, right? Minus 4 dt cube. Yes, Hafiz. Okay, you solved already, right? So now this is the velocity expression at time t is equal to 0. At time t is equal to 0, velocity becomes initial velocity, correct? You're asked to find what is the initial velocity. It's easy now. This term will be 0 when you substitute t is equal to 0. The last term also will be 0. There is a t and u is going to be what? B, right? Your initial velocity value will be B. Check out the options. The option with B as the first answer is the correct one. And unfortunately we have two options like A and C. Both of them says initial velocity is B. So we have to find out the second one also, acceleration. How will you find out the acceleration? Velocity expression can be differentiated once again. A is equal to dv by dt. What was the velocity expression? B plus 2ct minus 4 dt square. B, there is no t here, it is a constant. Differential of the constant will be 0. 2ct differential will be just 2c, correct? 2c minus, see, we have 3 and 2 here. 3 and 4, so it becomes 12 dt square, correct? 12 dt square. Acceleration at time t is equal to 0, you have to calculate. So the last term will be 0. And finally, acceleration, initial acceleration at t is equal to 0, its value is 2c, and these are the two values given, b comma 2c, option C. Yes, easy one, right? A is equal to, acceleration is 2c, velocity was b. So we have done so many questions in this format. Like what we have to do differently here is only to substitute t is equal to 0, right? Because you're asked to find what is the initial velocity and acceleration. Fine. Question number 14. Motion under gravity type questions, right? One example is given here. We'll just do that question also before winding up. A packet is dropped from a balloon which is going upwards with the velocity 12 meters per second. The velocity of the packet after 2 seconds will be. Usually these kind of questions we are getting confused with, right? A body is going upwards and we are going to drop something from it. Yes, see, the balloon is going upwards with a velocity 12 meters per second. We drop something from this balloon, 12 meters per second. If you drop something from that balloon, what happened to the body? If you drop a packet from this, see, let me drop a packet here. Will the packet go down instantly? For us, we see the packet is going downwards, right? But what actually happens to this packet? This packet also has an initial velocity 12 meters per second, I would say, in the upward direction. Do you agree? The body, yes, the body is having, the packet is having an upward velocity 12 meters per second. Because we know, we have done these examples before also, like when you sit inside a car and the car is running with 60 km/h speed, sitting inside the car, if you toss a coin, that coin comes back to exactly your hand, right? If the car is not speeding up or slowing down during this motion, if it is going with a constant speed, the coin that you tossed is exactly falling your hand, in your hand back exactly. And it is because when you move, actually the position when you toss the coin is changed. You moved a little forward before the coin comes back to you. But that doesn't affect the coin because the coin is also moving along with you in the car. So the whole system has a velocity. So if the car is moving with 60 km/h, you are moving with 60 km/h. The coin in your hand is also moving with 60 km/h in the same direction, right? Yes. So what happened to this balloon? I mean, like the packet was going up with 12 meters per second in the balloon. Suddenly it is dropped. Okay, at the time of dropping, what was the velocity of the packet? 12 meters per second. Why? Because it was moving along with the balloon vertically upward. Is that okay? Yes, Hafiz. Exactly. So this is going vertically upward. That is the only confusing factor here. It has an initial velocity 12 meters per second vertically upward. And we know motion under gravity, acceleration is going to be acceleration due to gravity, g, which is 9.8 meters per second square, right? You are asked to find what is the velocity of the packet after 2 seconds. We know the equation of motion, final velocity is equal to initial velocity plus acceleration into time square, t square. V is equal to u plus at. Yes, the next point you have to remember is the directions, right? Velocity you have taken plus, since it is going vertically upward. If you have taken velocity as positive, your acceleration should be negative because it is exactly in the opposite direction, correct? Yes, so final velocity v is equal to initial velocity 12 meters per second plus g should be minus 9.8 into 2 square. So we get 12 minus 9.8 into 4, right? Sorry, v is equal to u plus at, my bad, and there is no square here, right? And we get 2 only. Yeah, so finally this into 2, this is also going to be 2 only. So 12 minus 9.8 into 2 is going to be 19.6. Good. 19.6. 12 minus 19.6 is going to be minus 7.6 meter per second. Correct? So that is the final answer, final velocity, option C. Okay, so usually in the motion under gravity questions, this kind of sign convention is most of the time we commit mistake in that. So make sure you're okay with that. That all are coming under the basic concepts of motion. I told you what is displacement, what is velocity. When we deal with vector quantities, what should be the signs, right? Which one will be plus, which one will be minus. That kind of basic concepts you have to clear first. Then all these kind of questions are going to be pretty easy, because numerical values given will be very simple. Simply you can simplify it. Only the problem, actually normally usually we see the problem with the sign conventions. So make that perfect, then these questions won't be a problem at all. Okay, yes, so we have questions from motion graphs also. I hope we'll do after this. After doing this module in our regular discussion, we'll repeat the same module later, okay, especially the motion graphs part. Right? Yes, then we are going to wind up. If you have any questions, ask me. Otherwise, we'll stop now. Yes, Ruth, thank you. Yeah, okay then. Thank you all, and bye-bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.